For more information, please visit SGMAK Associates website.
In this module, I'm going to present two additional examples on mixed internal rate of return problem. We have talked about internal rate of return previously, and we have said it's applicable to simple cash flows only. Simple cash flows where you have a outflow followed by all inflows, or an inflow followed by all outflows only. So that's a simple cash flow, and in that IRR method is the recommended method. All that you do is you're solving for an unknown rate of return that makes the net present value of the project equal 0. So MIRR is used where you have both inflow and outflow throughout the project, and we use two separate rates of return. All money that goes into the project are borrowed at a borrowing rate, which is lower than all the outflow from the project, which are invested at a higher rate. So we have to use two different rates of return, one for borrowing and one for investment, and that makes the problem different from a traditional IRR approach. So let's look at a problem. We want to find the mixed internal rate of return. If you look at the cash flow, we have a cash inflow into the project. We're investing $15,000 and $8,000 in the beginning of the project, $8,000 at the end of year 3, and we have an outflow, money coming out of a project that you can invest end of year 1, end of year 2, end of year 4, 5, and 6. And we'll be using 12% rate of return that you can realize from all investment, and you're borrowing at a lower rate of 6% APR. So it's an example of mixed cash flow problem. So the approach is we find the net present value of all inflows to the project. So net present value of all cost that we input to the project is given by 15,000 now and 8,000 end of 3 years. So we use the appropriate conversion factor P over F. Discount rate is 6%, 3 years into the future. We bring it to the present, and that gives us a net present value of all cost. That's $21,706.80. Now we find the future value of all outflow, money that we generated from the project and we invested at 12% rate. They are at different points in time. We want to find the future value of this cash flow at the end of year 6. So we simply take every individual cash flow and move it to the future end of year 6 with the appropriate factor F over P, because we are moving from present to future. The discount rate is 12% in this case, and the cash flow at different points in time we take into account by using appropriate factor. So future worth, as you can see that expression, one cash flow we are moving 5 periods into the future, another one 4 periods in the future, and then we have 3 cash flow that we can treat as an annuity, and we find the future value at the end of 3 years. And that gives us a total future value for all benefits coming out of the project as $40,000, $40,560. So by definition, we find MIRR that takes the present worth of all cost at time 0 and can convert into a future worth of the money that we just computed. So MIR is that rate that will convert a present worth of $21,706.80 to a future worth of $40,560 end of year 6. So the expression is future worth is present worth multiplied by 1 plus MIRR raised to the power 6, because plan period is 6 years. And if we solve that, we get a MIRR of 11%. So project realizes a mixed rate of return of 11%. Let's look at a second example. We got 3 examples just to reinforce the concept. The second example, we have a 5-year project duration, and we got again a mixed inflow and outflow at different points in time. So it's a mixed cash flow problem. We're using an investment rate, money coming out of the project to be invested at 12% and borrowing rate of 6%. So in this case, similarly, we just find the present worth of all cost that we input to the project. So it's a 10,000, 103,000 at time 0 plus 87,000 using the factor P over F 6 and 2, bring it to the present, plus 8,300 at the end of year 4 using the factor P over F 6 and 4. Bring it to the present, and that gives us the present worth of all cost involved with the project as $187,003.60. Now we compute the future worth of all cash outflows. The discount rate is 12%. We got to keep that in mind. So now you're moving it from present to the future, end of year 5, with appropriate factor, discounting rate 12%, and that gives us a future worth of $318,652.8. Pay attention to the appropriate conversion factor. The one that is cash flow taking place at the end of year 5, we're moving into the future 4 years into the future. One that's happening end of year 3, we are moving into the future by 2 time period, and 38,500 is happening at the end of year 5. So we add that to the total as it is. So now we can compute the MIRR by simply writing the expression. Present future worth is present worth times 1 plus MIRR raised to the power 5, because plan period is 5 years. And that gives us the MIRR of 11.25%. So a mixed internal rate of return from this project with this cash flow with all the parameters as stated is 11.25%. This is a simple investment problem, so it's recommended that we solve is using IRR, but I want to also solve as an MIRR. So you got a down payment of $9,000 and plan period is 40 time buckets, 40 months. You're putting an annual cost of, you can think about buying an equipment for $9,000. Annual cost you're putting into the equipment of 500. You do it for 40 months, and then you get a future value out of that. 36,510. Better to think it as an investment. Initial investment 9,000, and the annuity investment of $500 end of each month for 40 months. And you get a future value. You can realize a future value of 36,510. So one approach would be, if we solve as a MIRR problem, find the present worth of our cost, which is 9,000 plus converting annuity into the present, gives us $27,085. And future worth is 36,510, and then that gives us an MIRR of about 0.75% per month or 9% nominal. But if we exclude the, this is a simple cash flow, we got a inflow to the project followed by just one outflow. So if we do that, we can solve it just an IRR, and you can exclude that 0.5% borrowing rate And you can find the IRR realized as, but just by setting net present value equals 0, we get a IRR of close to 0.75% or 9% APR nominal. So we get both nearly the same answers, but the problem really conforms to a simple investment problem, where you got inflows, all inflows followed by just an outflow. And very last year you have a net outflow if you look at it that way. So it's recommended that you solve it as a IRR problem. Because one reason is you cannot solve as a MIRR, because we couldn't, the way the problem is structured, we couldn't use the investment rate, which is typically higher than the borrowing rate of 1% per month. Okay, so these are a couple of examples on MIRR. We have told you about the signatures also for this problem, and hopefully this will be useful to you. Thank you.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.